Hello, I'm Dr. Ian McCullough from Johns Hopkins University, and this is a short lecture on neuromarketing. I think it's useful to go through some of the history of neuromarketing, and we'll go way back in time. Avicenna, not really sure how to say his name. It's also known as Ibn Sina, or Ibn Sina, was a physician, astronomer, and thinker and writer in the Islamic Golden Age. His big contribution to science was he's the first guy that discovered biomarkers as kind of an insight into inner emotional states. So he looked at pulse rate, skin, like sweat response, pupil dilation, as ways to understand emotionally what's happening in people. A number of years later, Robert Witt is a Scottish physician. He's the guy that kind of came up with involuntary reflexes, and he's probably more known for his work on reflex, meningitis, bladder stones, and just neurological states. He's like one of the key pioneers in neurology. But from a neuromarketing standpoint, he's the guy that was able to discover that the pupils had a reflex. So this is going from his muscle reflex to then pupil reflexes as a result of midbrain and decision-making reflex. So he's the guy that promoted the theory that when we respond emotionally to something, it actually creates a reflex inside of us that can be evidenced by changes in our pupillometry, and that if you can study pupil response to certain stimulus, you're actually seeing a reflex, which is the decision. So this is the idea that it's not some sort of rational, thought-out process in the decisions we make, that it's more of a reflex response. And then the guy to the right there is Galvani, is an Italian physician, and he discovered animal electricity. And so what you see there is he was the guy that found that if you basically applied electricity to certain muscles in a frog's leg, that it would cause a muscle twitch as an electrical response. So this animal electricity is then key in a lot of the methods we use today because we're measuring biomagnetics or electromagnetics in animal species. So these are kind of the pioneers of the field leading up to 1800. We'll now jump ahead, and we're going to look at William James, and this is part of the Jameslange Theory. So William James was a physician and psychologist. He actually taught the first psychology course in the U.S. And so the key point here is that our habits are going to simplify our movements, and that's going to reduce the cognitive intention or the energy we have to apply. And so the Jameslange Theory, in terms of how we make decisions, are that we see an event, right, in this case a snake, we then experience a physiological response, right, physiological response. We interpret that elevated heart rate, that sweat, that physiological response as fear. So what ends up, so this is important because what their experiment showed is, I think prior to this, the conventional thinking is you see a snake, you cognitively process the snake as danger and fear, and then that's evidenced by your physiological state. But what they were able to show through some experiments was that actually you respond physiologically to the stimulus first, and then emotion comes second. And the reason for that is there is a shortcut in the brain that the amygdala can shortcut the rational decision-making process to create the physiological response of fight and flight, and then you interpret that as emotion later. Now, people are like, well, how would you learn that a snake is dangerous, right? A person that's never seen a snake before would not necessarily have an elevated physiological response or think that. And that is true. But what happens, you see, is as a child sees a snake for the first time and then observes the parent's reaction, right? What ends up happening is they associate those stimulus and you become conditioned in your fear response. Right, so you become conditioned. But just like if you're familiar with Pavlov's dog, right, is there's a bell ringing when the meat is out there causing the dog to salivate. Then when the meat is removed and the dog just hears the bell ringing, it still creates that salivating response. So in the same way, you have a snake paired with a parent's fear response, right? That becomes conditioned now in the child. And so now when you remove the parent, when you remove that overt normative factor of fear, right, then there's still that association that exists. And it's that conditioned response that drives a physiological response, and we interpret the emotion later. And this is getting at what our brain is actually doing when it's creating these decisions that drive our behavior. There's two mechanisms that are at play in decision making. So this is going to draw more on Daniel Kahneman's research, and we have a system 1 and a system 2 brain. And please forgive the figure. It's not like system 1 is on the left side and system 2 is on the right side, or vice versa. It's a little more interwoven, intermixed than that. But we have this rational, deliberative brain. That's system 2. This is traditional market research measures this. This is what you're conscious of, what you're thinking of. And we usually can self-report that. If you're asking people to think logically about a task, if you're asking people to consider what they're thinking and what their process is, they can usually self-report that pretty well. But we also have this automatic response to external stimulus. It's very habitual. That doesn't really engage our more critical thinking. That's system 1. And this is where neuroscience can better target measurement of this system. And we also find that this is actually the system that's more involved in our consumer decisions. So continuing our study of cognitive psychology and the brain, there are cognitivists, right? And they believe that that the way people think is what impacts their behavior. So the way they perceive information, the way they process information, the way they remember information and code memory, all these things are going to affect their behavior. Right? And it's very difficult to resolve any kind of mental activity without the right technology to show how the brain in a particular area is impacting a specific behavior. So one of the early cases of that is the story of Phineas Gage. And for Phineas Gage, you see a picture of him on the right. He was a guy who was working out of, on a mine site, and there was setting some explosives, and an iron rod was blown completely through his head. It went in one side, out the other, causing the removal of a significant portion of his brain. And so this large part of his left frontal pole was destroyed, and the observation was that Phineas Gage was no longer Phineas Gage, right? He had a fundamental change in his personality. He had a fundamental change in his leadership skills, his ability to remain on task, and he really kind of led a sad and horrible life following this accident where he'd arguably been a successful man before. It was kind of a tragic case, but it allowed us to see how removal of certain portions of the brain affects your performance and your personality. So this gets into the idea of somatic markers, right? And somatic markers are feelings in the body that are associated with emotion. So there's certain areas of the brain that are tied to different types of emotion. And so this hypothesis states that the emotional process, right, or bias, they guide behavior, particularly with this decision making. And so it kind of is in line with the theory of William James, right, where the feelings are like this readout of the body, and that emotions are leading the decision making and social cognition. So the attitudes that you believe, how you view other people. It kind of ties into the whole belief echoes. It ties into our social psychology, how we perceive what other people think of us, right? What are the do's and don'ts? What are the norms? Those are all emotional outcomes that occur deep in our brain. And so these emotions have these biological underpinnings that lend us to understand consumer decision-making process if we can measure them effectively, right? And now somatic markers aren't necessarily brain imaging. somatic markers might indicate a number of ways to get at understanding those emotional states. So we're going to turn our attention to an early model of advertising, the AIDA model, which is attention, interest, desire, and action. So basically it's saying that if you're going to persuade somebody for a consumer decision, you first have to get their attention. Then you have to capture their interest. Then you have to tap into their desire, and then to the action. And it's meant as a triangle because you have to capture a lot more people's attention to capture their interest. Some of the people you capture their attention won't be interested. Some of the people who are interested won't have desire, etc. Right? And that was proposed over 100 years ago. We see that in social media and in modern advertising, right, where we change it a little bit. But in sales, we think of awareness, interest, prospect, and then sale, right? So that's just a different sales model, and we call that the click funnel. So in social media, you want to do something that captures people's awareness, then they get interested to click, then they read some information, right, and that causes them to take further action aside from your ad, and then that results in a sale. And then there's a lot of discussion as far as, do you want to increase the number of people going into the funnel, or do you want to turn that funnel into a cylinder? With consumer neuromarketing, right, what we typically do is, in traditional research, we have an environmental stimulus, like an ad, that we're testing. And then something happens inside the organism, and then there is a response. Approach, avoidance, they like it, they don't like it, something like that. With consumer neuroscience, what we're doing is we're adding this measurement of the emotional state, right? And we do that through pupillometry, eye tracking, neural imaging, galvanic skin response, a number of biomarkers, right, that tell us the emotional state, and that gives us greater insight or a better, improved model to be able to predict that approach or avoidance response. So another reason that we have these consumer measurement tools is there's bias in self-report, right? So if you're trying to anticipate your consumer behavior, if you're trying to anticipate what you're going to buy or not going to buy, and we're just going to ask you to fill out a survey, well, there's an interviewer bias. So there's a certain social conformity that comes into making sure that person that's conducting the interview approves of the answer that you're going to write. There is systematic error in our ability to actually estimate what we're going to do. There are all sorts of post hoc validations that occur after you've made the decision. And there's a general inability for us to even understand how we make decisions, right? We don't even like to admit that we are the victims of social conformity, for example, right? So there are all of these sorts of biases towards self-report, and that is why implicit measures can often complement those self-report measures and give you significant additional information. The advantages of consumer neuroscience. Right? There's a number of advantages. First of all, is it goes beyond the declarative state of a consumer. So the declarative state are the things that the consumer can accurately report about themselves. You can get additional information, such as how is their emotion playing into this, right? Is there counter-arguing? Do they have this engagement or approach from the stimulus, right? These are things that maybe they can't articulate very well, but you can capture. So an excellent example of this is in some of the tobacco cessation research I'm doing. There's this question about whether Red Sun's ad that says, hey, we have more nicotine than anything else, right? How people respond to that. And people report that that's a favorable ad, that people, want to show off and want to have high nicotine cigarettes. But neural response actually shows a disgust or a reproach from those types of stimulus in most people, that it's not an effective ad, but it's very inconsistent with the self-report, right? And we actually find that in vaping stores, they're more likely to sell merchandise of the high nicotine content products than actually sell them, because it's more of a social desirability issue than it is an actual desire for the content. Real-time or near real-time resolution into brain processes or proxies of those processes. So we're able to kind of get in and measure what's happening in the brain in terms of approach, avoidance, counter-arguing, depending on your technology, even is the reward circuit active, right? There's a great study of Coke and Pepsi. So the Coke and Pepsi taste test, if you don't tell people what the beverages are, they'll tend to report Pepsi, because Pepsi has a higher sugar content, creating an increased release of dopamine in the brain, and so people report liking Pepsi better. However, if you put them under an MRI and you see that, and then you tell them they're drinking Coke instead of Pepsi, you actually see that initial dopamine release, you see other areas of the brain get active, counter-argue, and then people report liking Coke better. And so you can actually get into the workings of the brain and understand how the brain changes attitude and perception and causes different decision-making to occur. We're able to capture transient processes that work to impact the decision outcome, kind of like I just mentioned. We're also able to reduce the bias inherent in explicit consumer responses. Right? We're also able to, like with respect to pricing, we're able to determine like kind of set points where the pleasure of an object exceeds the pain of paying, right? The Starbucks study. And in the Starbucks study, one of the interesting outcomes they did is for the small coffee, right? Their small coffee, they call it what? They call it a tall, right? So there's tall, grande, venti, as opposed to small, medium, large. And why do they do that? Because they find that a tall is going to create a different response than small. And so being able to measure that region of interest in a brand is a return on investment by fine-tuning your creative content can allow you to be more precise in delivering messages that are going to achieve the effect you want on consumer behavior. So there's some disadvantages to consumer neuroscience as well, right? It doesn't really tell you why people develop the observed reactions that they do, right? You kind of have to select people that have different backgrounds, and then you're kind of making some generalizations to that. It's almost always an artificial lab setting in order to use the tools that we use for neural imaging, especially fMRI or a PET scan or transcranial magnetic stimulus. Those all require like artificial lab settings. We're going to be talking about the functional near-infrared spectroscopy, which has a lot better ecological validity, although you're still putting a neural imaging cap with a bunch of wires on it, which is going to affect the environment, and that probably has some bias on how people respond. There's also an important concept called reverse inference. And so the reverse inference is this idea that if I expose people to stimulus under a variety of conditions and observe an area of the brain that becomes active, reverse inference would be when I show some new stimulus, I observe an area of the brain is active and I assume that there's a cognitive process behind it. That's called reverse inference. You have to be very careful with reverse inference, and the reason why is oftentimes brain regions are involved in multiple mental states, especially things like memory, right? Memory has areas that are fairly complex that are active across the brain. And so when you look at a particular brain region that becomes active, it might also be active in a number of other cognitive processes. And so just seeing that that's active doesn't tell you that it's a certain emotional state, for example, or a certain cognitive process is going on. It could be just indicated with a lot of others. An example of that would be the amygdala. Right? We think of the amygdala as being involved whenever there's a flight or fight response, but amygdala is also active in pretty much all emotional processing. So observing activity in the amygdala does not indicate fear, even though every time a subject is afraid, you'll see activity in the amygdala. Right? So that's reverse inference. So we need to look very carefully at a variety of studies and a variety of conditions before we conclude that a particular biomarker is indeed giving us information about somebody's mental state. There's also the price point and turnaround time of some measures, right? So fMRI, PET, TMS are very expensive measures, and depending on the market that you're doing, it might take a long time to do analysis of data. So depending on that, when is the right use of that technology to be able to test a product that's going to market? You might choose to, again, use something like functional near-infrared spectroscopy or eye tracking to get a lower cost, faster turnaround time on some of your measures. So when we look at some of the neural imaging technologies of the last 100 years, right, we saw initially EEG came out, and that was a natural extension of Galvani's animal electricity, that we could actually measure electrical activity not just in muscles but in the brain. So that kind of led to the EEGs of the 20s. Magnetic activity kind of then became a better source that we could do in the 1960s. That eventually led to anatomic imaging with a CAT scan. We then got better technology in the 80s with a SPECT and a PET scan, positronic emission technology, leading to the 1990s with the functional magnetic resonance imaging. And so functional imaging is where we're actually able to see different brain markers down to the voxel level. So we're actually able to see almost individual neurons firing or not firing based on stimulus. So it's amazing resolution down to like the millimeter level, much better, functional measurements of the brain. And then what's much more recent, right, since the last, the reason why it's in a different color there is in the 21st century, we now have the FNIRS. And the FNIRS is similar to fMRI in that it measures, regions of interest in the brain activation. But unlike fMRI, the FNIRS only has about a 2 centimeter penetration into the brain. So those deep brain regions, midbrain, hindbrain regions, are inaccessible to FNIRS. Even if you wanted to get to the ventral striatum, orbitofrontal cortex, where the reward circuit exists, not accessible with FNIRS. FNIRS also doesn't give you that very fine resolution of like millimeter to millimeter resolution. It's probably more like, a 2 centimeter region in the brain at the very surface level of the brain. So it doesn't have as much detail. But its advantage is it's using optical properties, so it's less invasive. It's also much more highly portable, as you'll see when we discuss that technology in the module later. You'll see that it's much more portable. It's much lower cost. And it still gives us valuable information. And so there's kind of this cost-benefit trade-off you have with FNIRS. Thank you for listening to this lecture. I'm Dr. Ian McCullough of Johns Hopkins University.